Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I'm going to talk about the chapter 3.5 Cartesian stress components from Shear Mechanical Engineering Design textbook. Okay, for the chapter 3. Okay, this is the Cartesian stress component which is represented by the X, Y, Z axis like this. Okay, so you can see introduction to Cartesian stress component, stress at the point of Cartesian axis, stress on the at a point, stress at a point within a body is described using Cartesian stress component using across three mutually orthogonal surfaces. You can see in the picture depicted in the textbook figure 3.7 and 3.8 like this. It is an orthogonal cubic, okay? So normal stress acts perpendicular to the surface aligned with the normal of the surface, and shear stress acts parallel to the surface. Shear stress acts along the different axis. Okay. So I have explained about normal stress and shear stress in the previous video. Uh, Normal stress, okay, normal stress acts perpendicular to the surface, that is stress act where normal is in direction in the x direction. Okay, for example, stress in x direction. Okay, shear stress act parallel to the surface, which such as tau xy, where shear acts in the y direction and on a normal surface to the x-axis. Double subscript for shear. You can see in the picture, whenever it is shear stress, it is depicted by the double subscript below. Can see the word tau xy, tau y x, and everything. This has double subscript, meaning that it is a shear force happen on it. Okay, on the stress and equilibrium reduction, simplification of stress component, cross shear equality. Whenever that item is in equilibrium, shear stress along the planes are equal. Okay, like this. Stress component reduction. This reduces the independent stress component from 6 or 9 to 6. Okay. Equilibrium condition. Shear stress on opposite faces cancel out. We want to simplify the analysis because if we want to calculate, it is hard to calculate because it has 9 components. So we make it simplify lah. Okay. Plane stress condition occurs when stress on one surface are zero, such as uh, Z0, TSZ0, atau ZY is equals to zero, because we we make it as zero to easy to calculate the stress on the plane. Okay. Application on thin object, commonly assume for thin object like plates on shell subject to in plane loads. Okay, three-dimensional element, even under plane stress, the object remain three-dimensional with stress acting on two planes. Okay, because everything is considered as a 3D object, even other in the even the surface is like you calculate on the two-dimensional plane. Okay, it is assumed as a three-dimensional plane. Okay, stress acting on two planes. Okay, so that's for the video right now. Inshallah we meet the next video. Thank you very much.